In this flip, we will discuss how the Nernst equation connects back to some of our previous concepts in this class. Reactions stop when one of the reactants is completely consumed, and we learned it in Gen Chem for the concept of unity reactant. However, a commercial battery stops operating at its rated cell potential before its reactants are completely consumed. This happens because the cell potential of a voltaic cell is determined by the concentrations of reactants and products. So how did the potential of a voltaic cell changes as the cell reaction proceeds and the concentrations of products increase and the concentration of the reactants decrease? Q increases, so the value of 0.0592 divided by N multiplied by log Q increases. Negative sign means value of E cell decreases as the reactants convert to products, and eventually E cell approaches zero. When it reaches zero, the cell reactions has achieved equilibrium, and the cell can no longer pump electrons through an external circuit. The cell is dead. When an oxidation-reduction reaction comes to equilibrium, there is no change in concentrations, and hence no electron flow and no electrical potential. That means that E cell is equal to zero, and we already know that at equilibrium, Q is equal to K. Nernst equation. That means that the equilibrium constant for an oxidation-reduction reaction can be found directly from the standard cell potential by setting the non-standard cell potential equal to zero. Log of K equals to N multiplied by E naught cell divided by 0.0592. Measuring potential of an electrochemical reaction allows us to calculate the equilibrium constant. K, E, E naught cell, and delta G all relate to each other. For example, positive cell potential, products favored, spontaneous reaction, thus positive K and E and negative delta G. Le Chatelier's principle can be applied to cell potential via the Nernst equation. If we change Q, we change E cell. So for example, removing products will make Q smaller, which also makes the natural log of Q smaller, or even negative. Since the cell potential is E naught minus RT over NF natural log of Q, that means that the cell potential would be higher. To understand the effect on pH, we would need to know if the acid or base molecules are on the reactants or product side of the reaction. For example, the reactions shown, hydroxide anions, are on the reactant side. That means that increase in pH is an increase in reactants and the cell potential will go up. A decrease in pH is a decrease in reactant concentration, therefore the cell potential will go down. From the information in this flip, you should be able to use the Nernst equation to examine equilibrium situation by setting E cell equal to zero.